In example 1, we want to determine our equivalent current source. We want to validate our expression with KCL. To begin, we see we have a voltage source V sub C that's connected to node A, where we have two ideal current sources IA and IB providing current to said node. Then as we progress upward to R2, I2 carries through and then back down to R3. At the bottom right hand corner we have R1 connected to the backside of our ideal current sources, as well as the negative terminal of our voltage source. To begin, we recognize that our current sources are in parallel. That is, IA and IB share the same node A at our outlets, and we can call our inlets node B. Since they are in parallel and they are in the same direction, we can say our equivalent IS is equal to IA plus IB. We will apply KCL to our original circuit. That is, at node A, we have I1 plus IA plus IB entering, and we have I2 exiting. Now, if we modify our circuit for our equivalent current source, we can represent our circuit as follows, where we have IS, which is equal to IA plus IB. And if we apply KCL at node A, which is condensed for our modified circuit, we have I1 plus IS is equal to I2, where IS is equal to IA plus IB. Thus, our equivalent current source formulation does not violate continuity.